Energy is the ultimate tool of humanity, from the movement of rivers to the burning of wood, coal, or green wind energy. For the many revolutions caused by these, nuclear fission stands as a turning point and a testament to humankind, a power source for destruction and creation. I will prove that the discovery of nuclear fission in 1938 changed history by developing a revolutionary form of energy, creating a weapon of mass destruction and creating nuclear power. All aspects of this discovery hold significance in our lives today through geopolitics and the need for green energy. Nuclear fission was discovered at the Kaiser Wilhelm Chemistry Institute in December of 1938. Otto Hahn and his colleague Fritz Strassmann discovered that lighter elements like barium were created while using neutrons to bombard uranium. They named this phenomenon fission, and Otto Hahn was given a Nobel Prize for it. Another scientist, Lise Meitner, explained with a model where the nuclei is a water droplet and a neutron a smaller one moving towards this nuclei. After impact, the nuclei would split due to the energy from the neutron. This is similar to random radioactive decay, but could be initiated. They theorized that if more neutrons were emitted after fission, it could cause a self-sustaining nuclear reaction which could lead to massive amounts of energy, whether for creation or destruction. Soon after the discovery of nuclear fission, World War II broke out. Einstein wrote to the then President Franklin Roosevelt about the power of a nuclear fission-powered bomb, saying, "Extremely powerful bombs of a new type may thus be constructed." They also feared that Germany would develop their own nuclear weapons, leading to the creation of the infamous Manhattan Project. One of these steps to the creation of the nuclear bomb was the first nuclear reactor, Pile 1. Pile 1 was the first known fission chain reaction, showing such a reaction could also be contained. Its structure had parts of current nuclear reactors, such as control rods. Pile 1 gave information about nuclear reactions to the Manhattan Project, leading to the creation of the atomic bomb and the Trinity test. However, the disdain scientists had for using the bomb was shown by the Slizzard petition against the use of the bomb, signed by 70 experts. These experts knew how damaging the bomb was. Government officials ignored the scientists' concerns, and after the Trinity test, they soon deployed the new weapons. The first demonstration to the world of nuclear energy was Hiroshima and Nagasaki. The bomb devastated the cities and quickly ended World War II, a clear sign of the nuclear bomb's strength. However, the tensions between USSR and America were growing during the war, and the demonstration of power sparked the Cold War. Nuclear weapons were a major topic of the Cold War, seen with events like the Cuban Missile Crisis. Unlike any other war, the Cold War had no direct fighting between the two, resorting to proxy wars and the space race. Both superpowers were able to obtain countless nukes and nuclear arms, soon as both America and Russia each have nearly 5,000 nuclear warheads. Both knew if fighting were to escalate to an invasion, they could very well use the nukes. Both developed the bomb in the name of defense, creating the hydrogen bomb fueled by fusion, and much stronger. We also created intercontinental ballistic missiles. This affected the lives of many everyday Americans by instilling a new fear, shown in videos such as Duck and Cover. As more countries were able to obtain nuclear arms, the anti-nuclear movement grew, especially with more harmful testing. At the end of the Cold War, partial test bans were written and more limitations were signed later. The nations created the Non-Proliferation Treaty, stopping countries from obtaining nuclear weapons. However, the strength of this treaty has been questioned, as some countries pulled out to obtain nuclear weapons, and India and Pakistan becoming nuclear powers with no international penalty. These are weapons of intimidation and destruction, and can be key in international relations, making countries with such weapons much more prominent on the world stage, such as North Korea. The first nuclear power plant was connected to a grid in Russia. While the power generation was not impressive at only 5 megawatts, it opened up the use of nuclear energy for beneficial and constructive use. Put simply, a nuclear reactor uses fuel from a fissionable material, each portion lasting much longer than fossil fuel. It fissions the fuel, and the heat is used to convert steam into water to turn a turbine and generate electricity. However, not all countries felt the need to build a nuclear power plant, as it was expensive and there was already infrastructure based on other fuel sources. However, there were some reasons to build one, as it could free countries from oil imports and cheaper electricity, and sometimes in secret to obtain resources for a nuclear weapon. Most of the construction of nuclear reactors happened around the 1970s due to the Yom Kippur War, tripling oil prices. Most chose the pressure water reactor, a type of light water reactor, as it was cheaper, simpler, and shown to work. However, this development and interest in nuclear power lasted only briefly, and the development of new nuclear reactors stagnated since the end of the 80s. With the infamous Chernobyl disaster in 1986, the Fukushima disaster in 2011. These events sparked concern. Despite that, more recently, people have been looking for alternatives to coal and oil because of environmental impacts. Nuclear energy is a viable choice and is more efficient on land use than green energy. There are no air pollutants, as nuclear only produces steam, and a fuel pellet 1 inch tall provides the same amount of energy as 1 ton of coal. We can see industries converting to electricity, like automobiles. This is done to prevent emissions, because electricity can come from non-emission sources. Nuclear power is already seen on ships, for the fuel is very efficient. There are 160 ships powered by nuclear reactors, including aircraft carriers and submarines. Nuclear propulsion is also on the radar for space exploration and longer missions. Likely in the future, as we become less reliant on fossil fuels, power options like nuclear will become more prevalent. In conclusion, the advent of nuclear fission in 1938 was a pivotal moment in history, with wide-reaching consequences continuing to shape our world today. The groundbreaking discovery and its development into a weapon, ending and starting wars, but also as the catalyst in the development of a source of nuclear energy for the benefit of humanity. Not only the geopolitical landscape changing, but also the threat of a weapon. This energy is a double-edged sword to create the weapon and the energy for electricity coming as a pair. The journey from a discovery in a lab to the signs of a new age, the atomic age, proves the significance of nuclear fission, connecting science and warfare, but also ethics and global relations. We must also be aware of history to understand the future.